So in rheology, another parameter apart from viscosity, another parameter that is very important is known as elasticity. Okay, so for semi-solids, these two parameters, viscosity and elasticity, are essential to determine the rheological properties of a semi-solid. So viscosity is defined by Isaac Newton, okay, which is means the resistance against flow, and viscosity is defined by Robert Hooke, okay, in that means it's a proportionality between force and extension of a spring. Okay, so what's the difference, viscosity and elasticity? All right, so as mentioned, viscosity is the resistance to flow when stress is applied. So for elastic material, okay, it stretch, all right, when the strain is applied, and just as quickly as it's returned to its original state. So when a material behave like this, like the rubber band, it's called like when you pull and it goes back to its original state. Once the stress is removed, these are known as the elastic material. So when you join these two words together, and often you will hear people say a viscoelastic material, okay, where the material have both these properties or both these elements, and as such can be dependent on strain. So something that is very viscous, okay, is called the is defined in the Newton law. All right. So the Isaac Newton defined resistance as the resistance which arises from the lack of slipperiness of the part of the liquid. Other things being equal is proportional to the velocity which with the parts of the liquids are separated from one another. Okay, which we've seen this equation earlier. And the n here is the viscosity, is the viscosity or the coefficient of viscosity. Whereas for the elasticity is defined as the power of any spring, is in the same proportional with the tension thereof. So this is known as the Hooke's law. The tau is equals to G and times the gamma, the strain, and G is the rigidity modulus. So this viscosity and the elasticity, the interplay of each other in the testing of semi-solid. So sometimes when using the rheometer, instead of continuous flow, a small oscillating stress is applied. Okay, so this is called as the oscillatory testing in semi-solid. So what does this oscillatory testing do? It helps to measure the structural strength of the semi-solid, the gel network integrity, and as well as the stability over time. So the rheometer will generate two when you do this oscillatory testing, it will generate two results. One is called storage modulus, is in the symbol with a single single like a comma. Okay, so this is called the G prime. So this storage modulus represents the elastic behavior. And what are these? This means that these are the energy stored within the material. It indicates the gel strength. So when you have high G prime, it means the internal structure is strong, and so the storage modulus is high. Loss modulus, which is indicated by G double prime, okay, it represents the viscous behavior. Okay, so high energy, this is the measure of the energy dissipated as it flows. So at high G double prime, it's more liquid-like behavior. So so just remember G prime is represent elastic, and then the G double prime is the viscous behavior. So in gels, creams, and ointment, okay, so often you see these kind of data being generated by the rheometer. Okay, the rheometer is an instrument that measures rheological properties of the semi-solid. So for gel, usually the G prime is more than G double prime because it's a more elastic material due to the strong polymer network and solid-like behavior at rest. Whereas for creams, it has moderate G prime and G double prime because it is a structured emulsion system with balanced viscoelasticity. For ointment, it's often viscous dominant, so the G double prime is higher than the G prime and has lower elastic recovery. So these are examples of the viscoelastic materials. You can see there's ketchup, hair gels, plasticine, even toothpaste.